All right, so as we've said, the phase of a material depends on its temperature and pressure. And so we can draw a little diagram where on one axis we have pressure, and then on the other axis we have temperature. And then depending on what these quantities are, it'll determine what kind of phase we have. So these typically look something like this. When we're at low temperature and high pressure, right, everything's compact. We don't have a lot of kinetic energy. That's a solid. So everything over here is a solid. High pressure, low temperature. Then we have the opposite, high temperatures, low pressures. Things are gases. And then in between, in the intermediate phase, we have liquids. And then we have a couple other points on this plot that we want to identify. One is this intersection right here. This is what's known as the triple point. This is where all the phases coexist, right? So gases, it's a gas, liquid, and a solid. They're all coexisting in equilibrium. And then we have this point over here with this part of the graph that we haven't identified yet. When the temperature and pressure get really high, we eventually reach the critical point. And then everything beyond the critical point is a supercritical fluid. And a supercritical fluid has properties between a gas and a liquid. So it's kind of like a gas, kind of liquid, like a liquid, but really a combination of both. You can check out your book for kind of more details about it. Then, of course, you want to kind of be able to interpret these kind of graphs, be able to identify, phase changes. So, for example, if we go from down here in yellow, from over here from orange to purple straight away, or the reverse, right? Those phase transitions would be sublimation / deposition. And so, right, we said we could avoid that liquid phase, and you can see you can do so as long as your pressures are low enough. Most materials have a pretty kind of similar phase diagram, just the actual values are going to change, right? What's the pressure, what's the temperature, that kind of thing. Water itself has a slightly kind of more interesting phase transition. And I've exaggerated it right here, but you can see how this one kind of has this, what they often refer to as like a negative slope. You can see this one kind of points up or even more towards the right, whereas this one is going towards the left, right? So what we can see is going on here with water is as pressure increases, we become more likely to be a liquid. Rather than a solid. And you might be wondering why. Well, water is one of the rare materials where its solid form actually occupies more volume than its liquid form. So as the pressure increases, we run out of space, right? Things get squished together more. It's actually more efficient for it to be a liquid because the molecules can pack tighter than in a solid. And that's because of its hydrogen bonding network. Right? In the solid, we have these really defined hydrogen bonds. And so there's some empty space that isn't used up in the solid, whereas in the liquid, they can roll around and get a little bit closer to one another. But overall, phase diagrams are pretty simple. Be able to draw one, be able to identify the areas, that kind of thing.